Everyone, good morning. So, in previous lectures, we have understand about the simple stress and strain. In that chapter, we have studied about the what is stress, what is strain, elastic constant, that is modulus of elasticity E. Then equation of delta L PL upon A. For tapering circular section, that is 4 PL upon pi E d1 d2. So, number of cases we have studied. After that, we have understand about the superposition, that is used for compound section having different diameter and the forces. For that, we have calculated that delta L, total elongation of the compound section. After that, we have studied about the composite section, and for that we have finding out the stresses in each material of the composite section and total force carried by the section. Now, after that, another thing that is most important for us, thermal stress and strain. In that case, all the things are remain same, but without force. Due to temperature variation, our element can be elongate or else contract. So, there is no force applied on any particular section, but after that it is elongate or else contract, means without force. Due to temperature, the length is increased and that elongation delta L will be calculated by the equation L alpha T. In that, L is equal to length of the member, alpha is equal to thermal coefficient, and T is equal to temperature. So, instead of P, here temperature is using important role. Another cases are same. So, in simple stress and strain, delta L calculated by the PL upon AE, and here in thermal stress and strain, the delta L calculated from the L alpha T. This is only a single change in these two chapters. So, thermal stress and strain is depending on the same thing. If is there any query, you can contact me. Now, after that, we are going to study about the elastic constants. What is elastic constant? We know about only a one elastic constant, that is E, but there are number of elastic constant in deformable bodies. Which are the constants that now we have to study? We know about the linear strain. What is linear strain? That is epsilon, and that is delta L upon L, that we have studied in our simple stress and strain. We know that linear strain means whenever we are going to apply force on the body, the length is increased, and that increased length upon total length, that is called linear strain. But what is lateral strain? We know that whenever the length is increased but diameter or the cross sectional dimensions are decreased, and that decrease is called as a lateral strain. If contraction is there, means length is decreased, so cross section of the member is increased, that is called lateral strain. Now, lateral strain measure to the linear strain is called lateral strain. For a round bar, lateral strain is equal to change in lateral strain upon original dimension. That we know. Suppose this is our element. The length is increased. Here to here it is increased, but diameter is decreased. Right? In the rectangular section, length is increased, but cross-sectional dimensions are decreased. Okay. So, for the rectangular bar, lateral strain is equal to change in width upon original width, or else change in depth upon original depth. That is lateral strain, and it is indicated by the epsilon dash. Now another thing, that is Poisson's ratio. What is Poisson ratio? Ratio of the lateral strain to linear strain is called Poisson ratio. Lateral strain upon linear strain means mu is equal to strain dash upon strain, means epsilon dash upon epsilon. Now we know that whenever we are going to apply force on the body, then length is increased, but cross-sectional dimensions are decreased. So, the volume of the whole element must be changed. Now, volumetric strain means a ratio of change in volume to original volume is called volumetric strain, means epsilon V upon V, that is called volumetric strain. Okay, epsilon V is equal to delta V upon V, that also we know that. Now, how we can calculate the volumetric strain for a single force acting on a body along with the length? The volumetric strain of a rectangular body subjected to an axial force. Consider a rectangular block subjected to axial tensile force P as shown in the figure. Length L, width B, thickness T, P is the tensile force, E is the modulus of elasticity, mu is equal to Poisson ratio, that is also called as 1 upon m. We know that stress is equal to P upon Bt, P upon A, and area of this cross section is equal to B into T. Now the longitudinal strain is equal to delta L upon L, or else sigma upon E, and the lateral strain, that is mu into epsilon. So, strain 2 is equal to minus 1 upon m, it is decrease, that's why it is equal to 1 upon m into sigma upon E. So, epsilon 2 is equal to minus sigma upon me, that is compressive. Now, delta L upon L is equal to strain 1 is equal to sigma upon E. Delta B upon B, epsilon 2 minus sigma upon me. Delta T upon T, that is epsilon 3 minus sigma upon m. Now, the volume of the element, that is L into B into T. So, delta V upon V is equal to delta L upon L plus delta B upon B plus delta T upon T. So, epsilon V is equal to stress upon E minus stress upon Me minus stress upon Me, right. So, we can say that the common from this sigma upon E, so 1 minus 2 upon m, right. So, it is delta V upon V. So, we can calculate the volumetric strain from here. Also, we can say that it is strain into 1 minus 2 into mu, that also we can say that. So, it is a simple, when a body is subjected to single force on a three-dimensional body, but whenever more than single force, what happening? Let's try to understand three forces on a three direction. Suppose this is our body, having x, y and z. This is x direction, this is y direction and this is z direction. Force is applied on the x direction, that is Px, and due to that force we can calculate strain in x direction, that is sigma x. Sigma in y direction, sigma y. In z direction, sigma z. Now we have to calculate volumetric strain for the body having three forces in each direction. So consider a rectangular body subjected to direct tensile stresses along three mutually perpendicular as shown in the figure, sigma s, sigma y and sigma z. There are three stresses. So we can calculate the three strain in that particular direction. Strain x is equal to sigma x upon E, strain y is equal to sigma y upon E, and strain z is equal to sigma z upon E. Now, whenever the three stresses in each direction, we can say that whenever strain in x, so that direction must be increased, but remaining two directions having decreased the dimension. So we can say that sigma x upon E minus sigma y upon me minus sigma z upon me. Same way sigma y, then sigma y upon E minus sigma x upon me minus sigma z upon me. In z direction strain, that is sigma z upon E minus sigma x upon me minus sigma y upon me. So this is the three basic equation is very much useful for us. So total change in strain means change in dimensions. Delta V upon V is equal to strain X plus strain Y plus strain Z. So this is the common equation for the three-dimensional forces on the body. So the total change in volume that calculated from this equation. But this equation is only used for the all forces are tensile. But whenever the force is compressive, that particular direction is change its sign. Got it? Let's detail understand in example. Now bulk modulus. What is bulk modulus? Bulk modulus K, that is equation for the K is direct stress upon volumetric strain, means sigma upon epsilon V. We know that how we can calculate stress and epsilon V for the particular case. So this is another elastic constant, bulk modulus. Now we have three major things: Young's modulus, that is E, Poisson's ratio, that is mu or 1 upon m, and the bulk modulus. From these three we can derive a equation, and we have to memorize that equation. How we can calculate that equation? There is no need to remember all the things. We must have to memorize that equation only, and that equation is E is equal to 3k 1 minus 2 upon m. Okay, we have to just memorize this equation only. Now shear stress and shear strain. What is shear? Means whenever we are going to apply force on a particular body, due to that force particular member will be cut off from the section, and this cutoff is known as shear, and due to the stress is produced over here, that is shear stress. When a body is subjected to equal and opposite forces acting tangentially across the resisting section, as the resultant it which body tends to be shear off, means cut off across the section, the stress induced is called shear stress. And the equation for the shear stress is equal to shear force upon shearing area. So F upon AS unit is Newton per mm square. Now, due to this shear, the strain must be produced over there. Whenever it going to cut off, means it will be from here to here deflect like this. So, here the angle is generated due to strain, and that phi is equal to C1 upon its length. So, we have to memorize these things also. This is also called as a shear strain. So, whenever an element cut off from the particular point, then there will be a two things produced. First one is shear stress and second one is shear strain. Okay. Now, another important thing, that is modulus of rigidity. What is modulus of rigidity? It is also indicated as C, N and G. Modulus of rigidity is equal to shear strain upon shear stress. Right? So, we can say that C is equal to tau upon phi. Now, we have another elastic constant, that is modulus of rigidity C. So, here again Young's modulus, Poisson's ratio and modulus of rigidity. From these three we can derive another equation, and that we have to memorize this equation. E is equal to 2g 1 plus 1 upon m. The relation between Young's modulus, bulk modulus and Poisson's ratio, the equation, that is E is equal to 3k 1 minus 2 upon m, and here E is equal to 3g 1 plus 1 upon m. Now, another relation, that is Young's modulus, bulk modulus and modulus of rigidity. Then we can derive the equation E is equal to 9gk upon g plus 3k. We have to memorize this equation. So, in elastic constant there are another 3, 2 and 1. Means third one, that is modulus of rigidity, second one is bulk modulus, and first that we know it is E, Young's modulus or else modulus of elasticity. From these three we can derive relation between them, and that is that equation must be memorized by us. This steel punch is used for punching shear, and that we have to study in next semesters. Right now it is not needed. So, you have to remember these things for particular cases. And another equation that we have, compressive stress is equal to compressive force upon compressive area, that we know. Sigma is equal to P upon A. Now, area we know that pi by 4 d square. So, d is equal to diameter of the hole and P is equal to compressive force. So, P is equal to F, that we can say. Now, shear stress is equal to shear force upon shearing area, and shearing area is equal to pi d into T. That we have to memorize. So, from this we can calculate number of things, but right now we have memorized some of the equation, and that equation first is linear strain, that is epsilon delta L upon N. Now, lateral strain, that is delta D upon D for epsilon dash is equal to delta D upon D for a circular section. But when a rectangular section, then there is a two lateral strain, that is epsilon dash is equal to delta T upon T and a delta B upon B, and that is always negative. After that, mu, Poisson's ratio, mu is equal to 1 upon m is equal to epsilon dash upon dash, sorry, epsilon dash upon epsilon, right? That we have to understand or memorize it. So these are the basic things that we have to used in this chapter whenever we are going to study about the cases. And the most important thing, that is, whenever any body is subjected to forces in all three directions, so at that time we have to use strain x, strain y and strain z, and equation for that strain x is equal to sigma x upon E minus sigma y upon me minus sigma z upon me, right? In epsilon y, that is sigma y upon E minus sigma z upon me minus sigma x upon me. Strain z is equal to sigma z upon E minus sigma x upon me minus sigma y upon me. These three equation is most important for us, and that we have to memorize in any cases or any condition. Clear? So after that we have to calculated all these examples, that is totally depending on the elastic constant. So thank you very much.